All right, we are going to talk about just a quick review over radicals and exponential functions. All right, so when we're talking about radicals, simplifying them is one thing. So remember, we're going to look for perfect squares, a perfect square that will multiply to something else to get that number. So I'm looking at 50. Well, looking through my list, I noticed 25. So 25 does divide out nicely. 25 times 2. And 25 is a perfect square, which gives me 5 square root of 2. Okay? So square root of 50 is going to simplify to 5 square root of 2. Now, looking at the variable, remember if it's an even number, I divide by 2, and all of it comes out of the radical. So since x to the 6 is even, 6 divided by 2 is 3, so I get x to the 3 outside. I need to shift this radical just a little bit. And then I'm going to do the same thing with the y. Okay, well, y isn't even, it's odd. But if I subtract 1, that leaves me y squared. Okay, so because it's odd, I know I'm going to have a 1 under the radical. And then I'm going to take and subtract 1 and divide by 2. Okay, really this one here is saying I've got the square root of y squared and times the square root of y. Oops, not what I was intending to circle. Okay, but so my answer is 5x to the third y square root of 2y. All right, we're going to talk about simplifying when we're adding or subtracting. So this one here is subtracting. So remember, we have to have like radicals. So I'm going to simplify the square root of 45 and see if I can get something that's, so we're looking at 45. Well, again, let's look for those perfect squares. I know 49 is not going to work. Let's try 9. 9 looks like a good one. So I've got 9 times 5. Well, 9 is a perfect square, which is 3 square root of 5. Okay, so 45 works. Or 45 becomes 3 square root of 5. Now, because this one has a 3 outside, I'm going to take 3 times 3, and then I can subtract. So 3 times 3 is 9, so I get 9 square root of 5 minus 3 square root of 5. Well, now I can subtract my coefficients. The number is in front. 9 minus 3 is 6. 6 square root of 5. All right, we're going to go ahead and simplify these. So I've got the square root of 20. Let's see if we can simplify that, and then we'll multiply the 3 in front. All right, 20 is, I can break down into 4 and 5. Well, 4 is a perfect square, right? 2 square root of 5. So I'm going to take 3 times 2, which gives me 6 square root of 5. Minus 3 square root of 2 plus, all right, now let's look at the square root of 18. 2 I know is already simplified, it's prime. Well, 18 is 9 and 2. Well, the square root of 9 is 3, so I get 3 square root of 2. Oops, 3 square root of 2. Okay, so now I'm going to take 3 times 3, which gives me, whoops, 9 square root of 2. So now I'm looking at my like terms. Okay, so or my like radicals, I should say. So the square root of 2. So I get 6 square root of 5. Negative 3 plus 9 gives me plus 6 square root of 2. And that's as much as I can simplify that one. All right. So now remember with multiplying, going to multiply the coefficients, and then I'm going to multiply the radicands, what's under the radical. So I'm going to take 2 times 4, which gives me 8. And then 12 times 15, which is 180. Oops. So now we're going to simplify 180. Let's see. All right, so I'm looking at my perfect squares, and I know 36, so it divides out of 180, and 5. Okay, well, the square root of 36 is 6, square root of 5. Now 6 times 8 is 48. So I get 48 square root of 5. All right. All right, so the next one is we're going to look at is when we've got division. Now I'm going to look and see if my fraction can simplify first. If my fraction can simplify first, I will simplify that. If not, I'm going to split it back into its 2, or split it into 2, so I get the square root of 25, and in this case 25 does not divide by 2 nicely, over the square root of 2. Well, the square root of 25 is what? 5. So I get 5 over the square root of 2. Now remember, I don't like radicals in the denominator, so I'm going to multiply both the numerator and the denominator by what's in my denominator. So in this case, square root of 2. Well, square root of 2 times square root of 2 gives me square root of 4 over, or sorry, under. In the numerator, I get 5 square root of 2. Well, square root of 4 can simplify, so I get 5 square root of 2 over 2. All right, so now we're going to quickly talk about exponential and differentiating exponential from linear. Okay. Linear tables, we will be adding. So notice on this one, I'm adding 5 each time. And on exponential, we will have to be multiplying by the same number. So they're both consistent, but I'm either adding or I'm multiplying. Linear adds, exponential multiplies. All right, and these two here are examples of exponential graphs, what they look like. We've dealt with linear before, they're a straight line. All right, so we're going to talk in this example about evaluating an exponential function. So guys, remember when we evaluate, all we're doing is taking what we're given and plugging it in for the appropriate variable. So in this one, I've got y is equal to 3 times 4 to the x power, and I want to find when x is equal to 5. So that means I'm just plugging in 5 for x. So wherever I see an x, I'm plugging in 5. And then I'm going to work this out. And I'm going to do my exponent first because of order of operations. So 4 to the 5th gives me 1024. And then I'm going to times that by 3. So we get y is equal to 3072. And that's all there is.